Hello guys, let's continue. Let's solve this very interesting problem number 45, and it says that white light incident on a 600 line per millimeter diffraction rating produces rainbows of diffracted light. What is the width of this first order rainbow on a screen 2 meters behind the grating? So let's start from drawing the problem. Here we will have our diffraction grating. Let's say this is our diffraction grating, okay, and 2 meters behind this diffraction grating we will have our screen. This is our screen. Let's say this is our first maxima, okay, our first central maxima will be here, not first but central maxima. So we will have here white light. Why white light? Why it is not like red or green and so on? Because when the white light passes through this diffraction grating, let's say this one is our white light, so we know that this white light consists of 7 lights, and each 7 light will create its own diffraction grating. Okay, diffraction, not grating, diffraction pattern or diffraction like fringes. So the angle of that diffraction pattern, okay, diffracted light, will depend on wavelengths of that light. So our wavelengths differs on the range of 400 nanometers and 700 nanometers. So from the equation of diffraction grating d multiplied by sine theta is equal to m lambda, we can say that sine of angle, okay, sine angle of diffraction depends on lambda. So it depends on wavelengths of the light. So more wavelengths means more angle. So basically what we will see here is this kind of rainbows. We will see here this kind of rainbows. Let me put it here, okay. So what is problem like asking us is to find the width of this diffraction rainbow, okay. Let's call the width like W. So to find that width we need to subtract from we see here our first maximum of red light, okay. It is located at distance, let's say y red, okay. This distance from the central maxima is y red. It is y red. We need to subtract from this y red this distance of y violet, because we see here the first maximum of our violet. Okay, now we understood that to find the width we need to subtract from y red y violet. Okay, we need violet, subtract y violet. Okay, let me draw the distance between this grating, okay, and screen is L, and the first maximum of violet light will be here, and it will be at this angle theta violet. Let's call it theta violet, and let's draw the angle of first maximum of red light. It will be here, and let's call this angle theta red. This angle is equal to theta of red, the first maximum of red light. So we need to find these angles. Okay, how can we find these angles? from the formula of diffraction grating, we can find these angles. So d sine theta is equal to m lambda. Okay, why do we need these angles? We need these angles because we know that from geometry course, yeah, we know that if we have right angle triangle, okay, right angle triangle, we can find tangent of that, of some angle. Let's say it theta is equal to, for example, in this problem, let's choose this right angle triangle. Okay, so to find theta violet, for example, theta violet, we need to divide y violet to L. We need to divide this wall to this distance. Okay, so we can find the tangent theta violet. From this equation, we know that we can find y violet will be equal to L multiplied by tangent of theta violet. And the same will be with tangent of theta red. It will be y red divided by L. And the same y red is equal to L multiplied by tangent of theta red. So now we know the distance L, but we don't know the angles. So let's find the angles from this equation. D sine theta 1 is equal to m multiplied by lambda. Yeah, or instead of 1, I should put here m. Okay, for violet it will be d multiplied by sine theta violet is equal to, as it's the first maximums of the fringes, so it will be just 1. I will not write it down, so I will just write lambda violet. So the same formula will be for the red light. D multiplied by sine theta red is equal to just lambda red. So from these two equations I can find sine theta, okay, violet is equal to lambda violet divided by d, and will be the same formula for our theta red. It's equal to lambda red divided by d. Okay, so if I know the sine of angle, I can find the angle by using calculator, or should I say arc sine. Yeah, theta violet will be equal to arc sine of lambda violet divided by d, and the same formula will be for theta red. It's equal to arc sine lambda red divided by d. So I know I found the angles, and I should put it to these two formulas, okay. So my main formula is located here. This one, my main formula. Width, we are looking for width, so width will be y red minus y violet. Y red is equal to L multiplied by tangent of angle theta red, but theta red is equal to arc sine lambda red divided by d. Okay, minus y violet. Y violet is equal to L multiplied by tangent of theta violet. So L multiplied by tangent of theta violet. Theta violet is equal to arc sine y violet divided by, lambda violet divided by d. So I'm closing it now. So this will be my main formula, or I can rewrite this equation as L tangent of arc sine lambda red divided by d minus tangent arc sine of lambda violet divided by d. I am closing no brackets. Okay, so I think that's all. No, I need 4. So yeah, that's all. Now let's calculate it. So width of this rainbow will be L equals to 2 meters multiplied by tangent of angle, tangent arc sine, okay, lambda of red light, it will be 700 multiplied by 10 power of minus 9 meters divided by d. D is equal to, so it's 600 lines per millimeter. Let me find the d. I don't know, maybe here. So I need to divide 1 millimeter to 600, or 10 power of minus 3 meters I should divide to 600. So this will be the distance between two nearest slits. So let me write it as 10 power of minus 3 meters and multiplied by 600. Minus tangent of arc sine lambda violet is equal to 400 nanometers. It will be 410 power of minus 9 meters multiplied by 600, okay, and divided by 10 power of minus 3 meters. So how many brackets do I need here? I think 3 is enough. Yeah, 3 is enough. Let's calculate then. I should use my calculator. Let's move this one to here. So it will be approximately, let me use calculator. Okay. So 2 multiplied by tangent of arc sine of lambda, it's equal to 700 multiplied by 10 power of minus 9 multiplied by 600 divided by 10 power of minus 3, and I should close brackets, minus tangent of arc sine 400 multiplied by 10 power of minus 9 multiplied by 600 divided by 10 power of minus 3. Okay, so it will be, my calculator says it will be 0.43 meters. Okay, 0.43 meters, or I can say that it's equal to 43 centimeters. So the width of this rainbow will be 43 centimeters. So that's all. Thank you.